Have you ever wondered how the atoms in your medicines hold hands to heal you? It all starts with a powerful invisible force which is known as covalent bonds. Hi, I am Dr. Swathi, and today we are diving into fundamental concept that literally holds your entire body and your medicines together. Whether it's glucose, DNA or aspirin, they all rely on covalent bonds, where the atoms share electrons to stay connected. But did you know some bonds are stronger, some are more reactive, and some decide if your drug dissolves more in blood or slips through the membranes? In this short video, we will simplify single, double, and triple bonds, compare polar versus non-polar covalent bonds, and most importantly, see why they are game changer in pharmaceutical chemistry. So stay tuned till the end of this video. So covalent bonds are formed due to mutual sharing of electron pairs. These covalent bonds can be classified based on the number of electron pairs shared between the bonded atoms into single bonds, double bonds, and triple bonds. There is another classification of covalent bonds is also exists, that is depending on the electron pair whether it is shared equally or not. So based on that, they are classified into polar bonds and non-polar bonds. Now let us deep dive into these types. So depending on the number of electron pairs shared, they are classified into single bonds, double bonds and triple bonds. Usually, these covalent bonds are formed between two non-metal atoms. Both the bonded atoms should be always non-metals. Now let us see first how single bonds are formed. So these single bonds are formed due to sharing of one pair of electrons. Let us consider examples, hydrogen and chlorine molecule formation. So in case of hydrogen molecule formation, two hydrogen atoms are involved. Each of the hydrogen atom, it consists of one electron. So let us say this is the electron of first hydrogen and this is second hydrogen with an electron. So these two electrons will be mutually shared between two hydrogens. So that is how hydrogen molecule will be formed. Now coming to the chlorine molecule formation, each of the chlorine, it consists of 7 electrons in its outermost energy level. So let us say the blue dots are the electrons of the first chlorine and the pink dots are the 7 electrons of the second chlorine. Okay, so out of 7 electrons, each chlorine, it donates 1 electron towards the bond formation. So that is how by mutual sharing of a pair of electrons between two chlorines, a single covalent bond will be formed like this. So for the single bond formation, a pair of electrons will be shared between the bonded atoms. So examples are hydrogen and chlorine. Now coming to the double bond formation, double bond will be formed due to sharing of two pairs of electrons. For example, in case of oxygen. So each of the oxygen atom, it consists of 6 electrons in its outermost energy level. So you can see here the blue dots are the electrons of the first oxygen and the pink dots are the 6 valence electrons of the second oxygen. So out of these 6 electrons, each of the oxygen will be donating a pair of electrons towards bond formation. So these two are the electrons from first oxygen and these 2 electrons will be donated from the second oxygen. So that is how by sharing of electrons here, a double bond is formed between two oxygen atoms, and that is how oxygen molecule is formed. Now coming to the triple bond, it is formed due to sharing of 3 pairs of electrons. For example, in case of nitrogen molecule formation. So nitrogen molecule involves association of 2 nitrogen atoms. So each of the nitrogen atom, it consists of 5 electrons in its valence energy level. For example, here you can see the first nitrogen electrons are shown in violet colored dots, while the second nitrogen valence electrons are shown in red dots. So each of the nitrogen, it is donating 3 electrons towards the bond formation. So by mutual sharing of these 3 pairs of electrons, triple bond is formed between 2 nitrogen atoms. So that is how nitrogen molecule is formed. So this is how, depending on the number of electron pairs shared between the bonded atoms, if there is sharing of 1 pair of electron, then a single bond. If there is a sharing of 2 pairs of electrons, then a double bond like in case of oxygen. And due to the sharing of 3 pairs of electrons, a triple bond like in case of nitrogen will be formed. So this is one type of classification of covalent bonds. Now the other type of classification is whether the electron pair which is shared between both the bonded atoms is shared equally or not. Let us consider AB is the given molecule. So this AB molecule is made up of AB bond. Bond means it consists of a pair of electrons. So this pair of electrons which are present between AB atoms can be shared equally or unequally. Depending on that, the polarity of bond, it changes. So accordingly, they are classified into polar bonds and non-polar covalent bonds. Now let us consider how these polar and non-polar bonds are formed. So due to unequal sharing of electrons between the bonded atoms, we get a polar covalent bond. So let us consider an example for that, that is hydrochloric acid, that is HCl formation. So in case of HCl formation, as I mentioned earlier, hydrogen atomic number is 1. So it consists of only one electron in 1s energy level. So let us consider this is the electron of the hydrogen. Okay, now coming to the chlorine, because it belongs to 7th group, it consists of 7 electrons in its outermost energy level. So out of 7, 1 electron will be donated towards the bond formation. Okay, 1 electron from each hydrogen and chlorine, they will be participating in the bond formation. That is how HCl bond will be formed. Okay, a single covalent bond will be formed between hydrogen and chlorine. Now coming to the sharing of electrons, if you see, the electronegativity of these two atoms is different. Okay, hydrogen electronegativity and the chlorine electronegativity are different. As you are aware that chlorine is a highly electronegative atom when compared with hydrogen. So that means as a result of this, whatever may be the bonded pair of electrons is there, this bonded pair of electrons will be unequally shared between both the bonded atoms, that is hydrogen and chlorine. Because chlorine has greater electronegativity, this bonded pair of electrons will be more distorted towards chlorine. So because of that reason, partial negative charge will be developed on the chlorine. Okay, while coming to the hydrogen, because the bonded electrons are moving towards the chlorine, hydrogen side it becomes electron deficient. Okay, so that is the reason hydrogen gets the partial positive charge. So this is how opposite poles will be generated across the bond. So such type of bond where opposite poles are generated, they are known as polar bonds, because due to the formation of the poles because of the unequal sharing of the electrons. So this is how HCl polar bond will be formed. Now same in case of water also. Water, the molecular formula you know that it is H2O. So here it is also the same thing here. Oxygen is electronegative in nature and it is bonded with 2 hydrogens on either side. Okay, so due to the greater electronegativity of oxygen, here even though there is mutual sharing of electron pair between one hydrogen with one oxygen on each side, okay, the bonded pair of electrons will be more distorted towards oxygen. So this is how partial negative charge will be developed on oxygen. Even with respect to the other OH bond also it is same. The electron pair will be more distorted towards the oxygen, due to which oxygen gets partial negative charge. While hydrogen side it becomes electron deficient, so hydrogen gets partial positive charge. Both the hydrogens gets partial positive charge. Okay, so the 2 OH bonds which are present in water molecule are also polar bonds. Now coming to the ammonia molecule, also ammonia, the molecular formula is NH3. Okay, the central atom is nitrogen. It is bonded with 3 hydrogens. Here 3 equivalent NH bonds are present in case of ammonia. But with respect to each bond, if you see, nitrogen is highly electronegative in nature when compared with hydrogen. So that is the reason the bonded pair of electrons will be more moved towards the nitrogen. So due to which nitrogen gets partial negative charge and hydrogens, all the 3 hydrogens, they become electropositive. They will get partial positive charge. So that is how 3 polar bonds are present even in the ammonia molecule. So this is how, due to unequal sharing of electron pair, polar bonds are formed, because poles will be dipoles. 2 opposite poles will be created across the bond that causes polarity of the bonds. On the other hand, when the 2 atoms involved in the bond formation equally shares, then we get a non-polar bond, because whenever the bond is equally shared, there will not be any creation of poles or dipoles. So we get non-polar bonds. Now in case of examples, hydrogen molecule formation, as I mentioned, in case of single bond, so each of the hydrogen, it consists of 1 electron in 1s energy level. So by donation of these electron, a pair of electrons, there will be formation of single bond between two hydrogen atoms. Now coming to the sharing of this electron pair, because both the bonded atoms electronegativity value is same, the pair of electron will be equally shared. Because of that reason, there is no creation of poles. Because there is no creation of poles, they are known as non-polar bonds. So the bond which is present in hydrogen molecule is an example for non-polar bond. Same is the case in case of chlorine also, because both the bonded atoms nature is same. Even though with respect to each atom, in case of chlorine molecule, it is highly electronegative. But the electronegativity differences between both the bonded atoms, because the atoms are same, the electronegativity difference is 0. So that is the reason the electron pair between two atoms of chlorine will be equally shared. So that is the reason there is no creation of poles, and thus chlorine bond, okay, that is the single bond which is present in chlorine, is also a kind of non-polar bond. Now let us consider a few examples of organic compounds which consists of these polar and non-polar covalent bonds. The first class of agents are alkanes. So you can see here methane structure is given. Methane, it consists of 4 equivalent CH bonds. The bond is formed between carbon and hydrogen. Okay, so these two atoms are having very slight differences in terms of the electronegativity. So the difference in the electronegativity becomes very small. Due to that reason, CH bonds are considered to be relatively non-polar when compared with the bonds which are present in alcohols and alkyl halides. The same in case of alkenes and alkynes also, because alkanes, alkenes and alkynes, all these three category of hydrocarbons, they basically made up of carbon-hydrogen bonds. Only the type of bond is different, that is the number of electron pairs shared are different. In case of alkenes, it is single bond, and in case of alkenes, it is double bond. In case of alkynes, it is triple bond, but the bonded atoms nature is almost similar. The electronegativity difference between these two bonded atoms is very small. Because of that reason is there will be almost equal sharing of the electron pair, and because of the equal sharing of the electron pair, there will not be creation of any dipoles. So that the nature of bond is non-polar covalent bonds. Now coming to this, some more examples of organic compounds, like in case of alkyl halides, if you see, we write the general formula as Rx. Now this R is nothing but the alkyl group. So here I have given a 2-carbon alkyl chain as an example. So if you see here, basically 3 types of bonds are present. Carbon-carbon single bond, carbon-hydrogen single bond, and carbon-halogen single bond. Okay, these are the 3 different types of single covalent bonds are present in this particular molecule. Okay, but they can be categorized into 2 classes. One is carbon-carbon and carbon-hydrogen bonds. I am just labeling it as 1 and 2. These 2 types of bonds are considered to be non-polar covalent bonds. They are considered to be non-polar covalent bonds. So in case of carbon-carbon bond, the nature of atoms are same. So the electronegativity difference is 0. So there will be equal sharing of electrons. So the bond is non-polar. In case of carbon and hydrogen also, the difference is very small. So they are also considered to be non-polar covalent bonds. Now coming to the carbon and halogen, this third important bond. If you see, the bonded electrons are shared between carbon and halogen. So as you are aware that halogen electronegativity is relatively high when compared with carbon. Because of that reason, the electrons which are present in CX bond will be more distorted towards the halogen. So that is how halogen element, whether it may be chlorine, bromine, fluorine, anything, it gets partial negative charge, while the carbon which is attached to the halogen gets partial positive charge. So this is how dipoles will be created across carbon-halogen bond, and that is how carbon-halogen bond is an example for polar bond. So here you can see a single molecule can contain both the types of bonds, non-polar bonds as well as polar bonds. So combination of bonds will be present most of the times in the organic compounds. Same is in case of alcohols also. Here also carbon-carbon single bond, carbon-hydrogen single bond, and carbon-oxygen single bonds are present. So there are 3 different types of bonds are present, and of course OH is also another bond, the 4th type of bond. So 4 different types of bonds are present, but all are single bonds only. So carbon-carbon and carbon-hydrogen bonds, these 2 types of bonds, they are non-polar covalent bonds as discussed earlier. But coming to the 3 and 4 bonds here, carbon and oxygen bonds, the electronegativity differences are greater here between carbon and oxygen. So due to which oxygen gets partial negative charge and carbon gets partial positive charge. Okay, that means poles are created, dipoles are created across the bond. That is the reason this carbon-oxygen bond is an example for polar bond. Same is in case of OH also. That means a bond which is shared between oxygen and hydrogen. Okay, so here also oxygen electronegativity is great when compared with hydrogen. So because of that reason, the bond will be distorted towards oxygen more. So oxygen gets partial negative charge and hydrogen gets partial positive charge. So this is OH group is also an example for the polar bond. So that is how alcohols, they also consist of both polar as well as non-polar covalent bonds. Same in case of the other types of organic compounds such as carboxylic acids also. So here also carbon-hydrogen and carbon-carbon bonds are non-polar bonds, but the carbon-oxygen bond, okay, and also carbon double bond and carbon single bond oxygen bonds, these are polar bonds. Due to the unequal sharing of the electron pair, there will be creation of dipoles, hence these bonds are polar bonds. So this is how covalent bonds are classified into polar and non-polar covalent bonds depending on the extent of sharing of electron pair between them. Coming to the reactivity of molecules, single bonds, they are the stable bonds among all types of bonds, but they can offer free rotation. In case of double bonds, these double bonds are the site for addition reactions which are crucial in pharmaceutical industry. But at the same time, there will be restricted rotation around carbon-carbon double bonds. Now, while coming to the triple bonds, they are the strongest bonds and they usually restrict the rotation around the triple bond, but also they are more reactive in certain reactions. So medicines often contain combination of these bonds and thus they affect how they interact with the body. In pharmacy, drugs with polar groups and non-polar groups, they are having their own importance. For example, drugs with polar groups, they dissolve in blood better. While coming to the compounds which are having non-polar groups, they can cross the cell membranes faster. So understanding the bond polarity helps to predict solubility, bioavailability and drug action. I drop new videos every week to help you master chemistry with clarity and confidence. See you in the next one. Don't miss it. Thank you.